Welcome to Math with Mrs. Bibb. I am going to go over the Facts to Know quadratics sheet. This is just a supplement to the notes that you have taken at home for homework, so this is like a quick reference guide. Standard form. If you'll make sure to pause and copy down everything that you see there that it says for standard form. We will do the example on the next slide. So I had started this example when I did my recording, so you can see that in this standard form, I named A, B, and C, and I started finding the axis of symmetry using x equals negative b over 2a. So I substituted 6 in for b, so negative 6 would be positive 6 over 2 times 1. I did my multiplication first and got 2, and 6 divided by 2 is 3. So my axis of symmetry is x equals 3. And now I'm going to find the y-coordinate of my vertex, and it says to find the y-coordinate of your vertex, you substitute 3, or the x-coordinate, into the original equation to find that y-coordinate. So I'm going to substitute y equals 9 minus 18 plus 13. So y equals negative 9 plus 13. Y is 4. So that's my vertex. Next, I'm going to name the direction that it opens. I don't have one of those papers in front of me, but let me look for it. I want to do it in the same order it says. Yes, the direction that it opens. A is positive 1. Since A is positive 1, it is not a reflection across the x-axis, so then that means it opens the same direction as the parent function, which is up. My domain, the domain for all the parabolas that we're going to be doing, maybe we'll get to more that do not have this domain, but negative infinity to positive infinity is my domain for that particular standard form. The range. Since I know that it's pointing up, let me graph this. Let me plot 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, and I know it's pointing up, so that means it's going up towards positive infinity. So positive infinity will go here, and it starts at the y-coordinate of the vertex, which is 4. So from 4 to infinity. And you put a bracket because 4 is included. Next is where it's increasing and decreasing. I'll do that in just a second. And then the y-intercept. And then the max or the min value. And I know that it has a minimum value since it points up. It has a minimum. And remember, the minimum is your y-coordinate of your vertex. Whoops, I don't need to write that. So the y-coordinate of the vertex is 4. That's the minimum value. My y-intercept is c, so c is 13. So I'm going to go up to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is my y-intercept. And that y-intercept is 2 units from the axis of symmetry. 1, 2 units. So that means 2 units the other direction. There's a point that's reflected across. So I will plot that. So 2 units on this side. And then try, you will know that I don't do a very good job on the smartboard, but that's not too bad. That's my graph of that equation. And now I want to talk about how I do increasing and decreasing. This is the left, this is the right. It is going down over here and then going back up on the right. So it is increasing to the right of the x-coordinate, which is 3. So it's decreasing to the left of 3. Follow your arrows. Decreasing, going down, going back up, decreasing, increasing. And I believe that's all the information we need for standard form. Now let's go do vertex form. Vertex form. Please make sure to fill in the things that I've written in for you. I did add this y-coordinate here. It's the y-coordinate of the vertex for your range. So make sure you fill those in. Pause the video and fill that in. Not much missing there. Now for vertex form, we will find the vertex first. It's very easy to find the vertex. This is left 4, down 5. Left 4, down 5. And the axis of symmetry is x equals -4. The direction that it opens, this is an indicator that we have a reflection across the x-axis. So that means that it is not pointing up like the parent function, it's pointing down. So down is my direction. Since it's pointing down, that means it has a maximum value. It has a highest point. That maximum value is the y-coordinate, that's -5. Let me go ahead and find the y-intercept so we can graph it. And on your paper, the y-intercept tells you to substitute 0 in for x and simplify. So I'm going to substitute 0 in for x and simplify. Do order of operations. 0 plus 4 is 4. Do my exponent next. Multiply. So I get -37. Okay, so I'm going to graph -4, -5. -4, -5. So there's my vertex. The axis of symmetry is going to go through the vertex. And then I don't want to count down to -37, so I'm going to go down here and I'm going to put -37. I'm going to reflect this point across the x-axis. This point is 4 units from the x-axis, the axis of symmetry. So this point is 4 units from the axis of symmetry. So I'm going to go 4 units on the other side. 1, 2, 3, 4, and come down. And then I'm going to draw okay. There's the graph. And I'm going to use red just for me. Some of you won't have to do this, but I like to do it because it helps me make sense of the problem. Left and right. And so that means it is increasing. I know I have to do domain and range, and I will in just a moment. It's increasing to the left of -4. It's always your x-coordinate. It's decreasing to the right of -4. And domain and range. Will that be everything I need? Axis of symmetry, vertex, direction of opening, maximum in, domain range. Yes. Okay, so my domain is -infinity to +infinity. And my range, since it's pointing down, it's going towards -infinity. So -infinity. And then it stops at -5 with a bracket. So that's my range for vertex form. Next, we have intercept form. If you'll flip your paper over and then write these things on the back, and I would pause the video and give yourself time to write that down. Intercept form, y equals x minus p times x minus q. And your P and your Q are found exactly the way we have been doing the other things in class. Your left or right movement. Or you can use the opposite, like this would be the opposite of whatever that number is. Okay, so to find your vertex, your x value goes here, and you substitute that x value into the original equation to find y. And remember, your maximum or your minimum is the y-coordinate of the vertex, and your y-intercept, you substitute 0 in for x and simplify. And I believe there's an example on the next slide. Yes. So here's my example. My x-intercepts are P and Q. And this is left 3, right 5. And so left 3 would be -3, right 5 would be +5. So those are my x-intercepts. My axis of symmetry is x equals P plus Q. This is P, this is Q. So x equals P plus Q divided by 2. So x equals 2 divided by 2. So x equals 1. That's the axis of symmetry. And then for my vertex, I know 1 is the x-coordinate, so I'm going to substitute 1 into that function to find y. So y equals -2 times 4 times -4. So y equals -8 times -4. So y is -32. Now, I wrote on those other things how to find your max or your min, which is always your y-coordinate. And this one will actually have a maximum value because it's a reflection across the x-axis, so it'll have a maximum value of -32. But I don't need the y-intercept. You can find it, but I don't need the y-intercept to graph because I can graph my x-intercepts, -3, +5, and graph my vertex, 1, -32. Oh, it's +32. Bet you all caught that already, didn't you? 1 and +32. So 1, was it +1? And +32, yes. And you can actually just go ahead, I guess I should draw my axis of symmetry. So there's my graph of that equation in intercept form. And again, like I said, your max value is your y-coordinate of your vertex. It's a maximum because it's the highest point. And I think you all know how to find all the other information. Okay, I hope that reference guide helps you with many problems.